37 times, so that will give us 4 times 37. I'm just double checking that. Yes, that will give us 4 times 37. Square root of 4 is equal to 2. There is no square root of 37, so 2 root 37 is our answer in simplest surd form. Alternatively, we could have got to an answer of 12.17 units, rounded off.
We are now going to take a look at a few cumulative examples. What you need to remember about analytical geometry is that it is a very all-inclusive type of section in mathematics. You use a lot of different concepts through each question that you do in analytical geometry. It's very rare that there's only one way of working something out, or that you only have to use one concept. We'll start off by going through a few basic examples. We'll then progress on to cumulative examples. All of that I want you to have a go at on your own. Press pause on your DVD player, and when you return, we'll go through it together.
The first question I gave you to do had this diagram over here, and the first question was determine the length of BC, AB and AC. Thankfully we've got all of the coordinates, so it's pretty easy to do. Firstly, the length of BC is going to be given by square root of y2 minus y1 squared, which is going, let's just write that out, y2 minus y1 squared plus x2 minus x1 all squared, and that's all in the square root sign, which is going to be given by square root of y2 minus y1, which is 2 minus 0 squared, plus x2 minus x1 squared. 2 minus 0 is 2, squared is 4, plus 4 minus minus 5 is the same as 4 plus 5, which is equal to 9. 9 squared is 81, which means that our answer is square root of 85. BC is equal to root 85. Do I need to simplify it further than that? In this case, don't. Leave it just as is. That's for BC. For the next one, AB, AB is equal to square root of y2 minus y1, so that's going to be 2 minus 4, or rather let's do it the other way around. Now 2 minus 4, 2 minus 4 squared plus x2 minus x1, which is 4 minus 3 squared, is equal to 2 minus 4 is negative 2 squared is positive 4, plus 4 minus 3 is 1 squared is 1, which is equal to positive 4 plus 1 is 5, square root of 5. That's the distance AB. So we know that BC is equal to root 85. We know that AC is equal to root 5. Last one, AB is root 5. Last one, AC. AC is going to be given by square root of y2 minus y1, 4 minus 0 squared, plus x2 minus x1, 3 minus minus 5, or 3 plus 5 squared. 4 minus 0 squared is 16, plus 3 plus 5 is 8 squared is 64. 64 plus 16 is equal to 80, all in the square root sign. Again, do I need to simplify it any further? Not in this case. You don't have to. This last one though, we can simplify it a little bit further. Root 80, 4 goes into 80 20 times. In fact, I lie, 16 goes into 85 times. Square root of 16 is 4, 4 root 5 is equal to root 80. So I can leave it in that answer. Alternatively, I could have just left it as root 80. That's fine. Root 80 is not the simplest third form though, but I'm not too bothered about that. Okay, that's the distance of BC, that's the distance of AB, and that's the distance of AC. Always remember, golden rule, it doesn't matter which point you choose as point 2 and point 1. You could have said y2 minus y1 over x2 minus x1, or rather plus x2 minus x1 squared. But if you chose this point as point 2, y2, that has to be x2. You can't say y2 and x2. It has to be y2, x2, y2, y1, x1. Alright, keep that in mind. Okay, but that's the distances that was asked for. Then number 2 says, if is ABC, triangle ABC, a right angled triangle with BC being the hypotenuse? Well, if it is a right angled triangle, let's just write this other figure in there, that's root 80. If it is a right angled triangle and BC is the hypotenuse, in theory the hypotenuse squared should equal the two sides added together squared. Yes? Or the two sides squared added to each other. Basically that means that if BC is the hypotenuse, BC squared is equal to AB squared plus AC squared. Let's see if that holds true. AB squared is equal to root 5 squared plus AC squared is root 80 squared. Root 5 squared is 5, root 80 squared is 80. So that's going to give us 85. BC squared is root 85 squared, which is equal to 85. That means that this holds true. AB squared plus BC squared, AB squared plus AC squared is equal to BC squared, which means that that is a right angle triangle. The next one asks us, what are the coordinates of M, the midpoint of BC? So M, the midpoint of BC, I'm guessing it's going to come somewhere over there. Remember that the midpoint is the x value is given by x2 plus x1 over 2, and the y coordinate is given by y2 plus y1 over 2. That means that M, the coordinates of M, the midpoint, are going to be given by x2 plus x1, so it's going to be 4 plus minus 5 over 2, and the y value is going to be 2 plus 0 over 2, which means that now 4 plus minus 5 is equal to negative 1. Negative 1 over 2 is equal to negative 1 over 2. And the coordinates of the y coordinate rather is 2 plus 0, which is 2, divided by 2 is 1. That means that my graph is drawn very inaccurately. It should be somewhere over there, with the x value being negative a half and the y value being 1. That's the coordinates of M, my midpoint of BC. Let's write it a little bit neater. It's negative 1 over 2 and 1. The next question says, what is the size of alpha? And alpha, I forgot to draw it in, is over there between those two lines.